and welcome back to Chuck's Corner, where I share real stories from CNC manufacturing. Today's story isn't about feeds, speeds, or some fancy 5-axis toolpaths. It's about something far less glamorous and far more disruptive. The day the chip conveyor quit. We were running a solid production job in 4140 heavy roughing, high material removal, chips flying exactly the way you'd like to see them. Cycle time was dialed in, tools were holding up beautifully, everything was smooth, until it wasn't. About 3 hours into the shift, the surface finish started going sideways. Then the spindle load began creeping up. Nothing dramatic, just enough to make you uneasy. We paused the machine, tool looked fine, offsets were stable, coolant pressure was solid. Then we opened the doors, chips everywhere. The conveyor had quietly stopped running about 40 minutes earlier. No alarm, no flashing light, just a slow build-up of hot steel chips recutting underneath the tool. What started as a chip evacuation issue slowly turned into heat, load variation, and an inconsistent finish. The cutting parameters were perfect, the tool assembly was perfect, but the environment around the cut wasn't. We cleared the conveyor, restarted it, cleaned the enclosure, and hit cycle start again. Spindle load dropped back to normal, and the finish cleaned up instantly. CNC performance isn't just about the tool and the program. Chip control, coolant flow, maintenance, it all matters. Manufacturing is a system, not a single variable. And that's also why documenting your tooling setups, assemblies, and job data matters. When something does go wrong, having clear records of what tool, holder, and parameters were used makes troubleshooting faster and far less stressful. If you want to see how tooling data and assemblies can be organised and documented to support your jobs, check out MachiningCloud. Thanks for stopping by Chuck's Corner. Stay safe, stay sharp, and own the process.